Guys, good morning, good evening, good afternoon, wherever you're sitting. We actually had planned to do this as a Zoom meeting because we thought that we'll have a few people and we would, work with their own uh, workflows. But for some reason, my initial video that I had put in went to was viewed by a lot of people and there was a lot of interest, so thank you very much for your interest, not complaining, but we had to move the channel a bit. So I'm Ibrahim Malik, and over the past 3 decades, right, working in IT and education, I have witnessed automation evolve from like a simple scripts to complex AI powered ecosystems that drive entire business operations. As an AWS certified solutions architect professional, AI practitioner, machine learning specialist, and a CCIE emeritus, I've had the privilege of, designing and troubleshooting automation systems for organizations ranging from startups to enterprises. Today, I'm going to share with you what separates automation that works on demo day from automation that delivers consistent business value in production environment. I tell people that look, automation is not new, right? I mean, everyone talks about it, but the first project that I've worked on in automation was actually in 2004. I used to work for uh, I used to work for AT&T at that time, and AT&T's client Citibank had a call center in Manila. And our task was to reduce the wrap up time from 5 minutes that it took call center agents at that time to something smaller. So after screen scraping and listening to the conversation, we were able to reduce that to 30 seconds. And that saved the bank, a lot of money, although the cost of product that project was also very was a lot. Okay, so like I said, it is nothing new. It's been around, and we are going to cover it in the next hour. Isn't theory from textbooks, okay? It's a strategic framework built from actual production failures, successful recoveries, and the hard-won lessons that come from deploying automation at a scale. So I have a lot of scars to show. I have failed quite a lot, and that's how I've learned, right? So whether you are currently struggling with automation that require constant manual intervention, or you're planning your next automation initiative, right? This framework will give you a systematic approach to building systems will actually deliver ROI. So let me be direct about something. Upfront, automation is not about eliminating humans from processes. Okay, that's a fundamental misconception that causes most automation projects to fail. Automation is about optimizing where human expertise is applied, moving people from repetitive, low value tasks to high impact decisions, decision making in a strategic workflow. So when you understand this principle, everything else we discussed today will make more sense. So here is what we will accomplish together in this hour, right? So first, we will diagnose why automation initiatives fail to scale using real data, okay, and patterns that I have observed, and then you can actually go and check the other subject matter experts, and you'll find similar. Second, I'll walk you through a specific resolution strategy, not abstract concepts, the actionable frameworks you can apply starting Monday morning. Third, we will build a 30-day roadmap that takes you from where you are today to where you need to be. And finally, I'll share where you are ready, where you are ready to where you need to be, right? So, and finally, I'll share 5 core principles that underpin every successful automation. So with that said, let me go to the next slide. And you know, here's the statistics that should concern every technology leader, right? 73% of automation initiatives fail to scale beyond their initial development. So MVP, up until MVP, everything is fine. But think about for a moment, nearly three-quarters of the time, money, and energy invested in automation never delivers the promised business. Why? I'm going to show you the three root causes, and then we'll explore a practical framework for addressing each one. Let me tell you about a firm, a mid-sized e-commerce company. Of course, I'm not going to name them. That had built what they thought was a sophisticated order processing automation. On paper, it looked beautiful. All right. Completely beautiful. Connected with shopping cart, to inventory management, to shipping systems. The customer notifications worked perfectly in testing. So MVP was pretty cool, right? Then they went live. And within first week, payment gateway API had a 10-hour outage. You know what happened? Every single order during that period failed completely. Not queued, not retried, just failed. They had to manually reconstruct transactions from incomplete data, refund confused customers, and salvage relationship. The problem wasn't that payment gateways outage, right? APIs fail. That's a reality. We have all know that. I mean, everything fails. The problem was that automation had zero self-healing mechanism, no retry logic, no fallback procedures, no graceful degradation. When one component failed, the entire system collapsed like a house of cards. This is what I mean by lack of resilience in design, right? Uh, so most automation builders designed for the happy path when everything works as expected. But the pros, right, designed for failure because failure is guaranteed, my friends. Whatever you build is going to fail at one point or the other. The question isn't if your external dependencies will fail, but when and whether your system can handle it. Okay. The second pillar is tight coupling, building point to point integrations where your automation directly depends on external APIs, data formats, and service behaviors. I see this constantly, especially with teams that are moving fast and prioritizing quick wins, right? Here's why, tight coupling destroys the scalability. When the external API changes, and they always do, your automation breaks. Not just one workflow, but potentially dozens or hundreds that are all directly depend on that specific API structure. I can tell you about a financial services firm who had built about 47 different workflows, all making direct calls to Salesforce API. Salesforce announced a major API version upgrade with a 6-month deprecation notice. Sounds reasonable, right? Yeah. Except updating those 47 workflows required touching each one individually, testing each one separately, and coordinating deployments across multiple teams. The migration took 4 months and cost more than the original automation build. The alternative which we implemented for their next integration was an abstraction layer, right? A single internal API wrapper that all workflows call, then handles the external Salesforce communication. When Salesforce changed, we updated in one abstraction layer. All 47 workflows continued working without modifications. That's loose coupling. Okay. And it is the difference between maintainable automation and technical debt. And the third root cause is insufficient observability. Uh, so the third failure mode is what I call the black box automation, right? Systems where you have no visibility into what's happening until something breaks. Then you're debugging reactively, trying to piece together what went wrong from incomplete error messages and user complaints. So last month, I was brought in to troubleshoot an automation that was sometimes failing. Okay. The team couldn't tell me how often, which data cause failures, or when or where in the 23 node workflow the problem occurred. Their debugging process manually rerun failed workflows and watch the screen. At the enterprise scale, this is completely untenable. You cannot continue to do this. Insufficient observability manifests in three ways. Okay. First, no centralized logging. You can't reconstruct what happened. Second, no performance monitoring. You can't see degradation before it becomes critical. Third, no proactive alerting. You only learn about failures when users complain. Now that you understand these three failure mode, right? And before you can fix automation problems, you need to understand which of these three categories or what combination is causing your issues. Are systems failing without recovery? Are external API changes breaking workflows? Are failures invisible until they impact users? Clear diagnosis is the foundation of effective resolution. Okay. So, what I call the digital theater solution framework, I mean, you can use it yourself too, right? Deploy, deploy, with observability built in. Observability isn't something you add later. Right? It's architected from the beginning. Every workflow should log execution data. I'm not asking for too much. Every integration point should track performance metrics, right? Every failure should trigger appropriate alerts. So when these are built in, debugging transforms from detective work to a analyst work. I would much rather do a data analyst work than a detective work, right? This framework that I'm talking about, diagnose, design, deploy, is what I apply to each problem patterns throughout whenever I'm encountered, right? So keep these three steps in mind as we go deeper. All right, so let me move to the next slide. So look, now let's tackle one of the most frustrating paradox in automation. You build systems specifically to reduce manual work, yet they still require, constant human intervention. Why does this happen? And more importantly, how do we fix it? Right? So the situation is this: organizations deploy automation expecting dramatic reductions in manual effort. The business case projects 80% reduction in processing time, significant cost savings, right? Improved accuracy. Your team is still fixing failed workflows, right? Then reality hits 3 months after the deployment. Your team is still fixing failed workflows, manually handling edge cases, and spending hours troubleshooting issues that should be automated. I've seen this pattern dozens of times. All right, uh, the automation works technically, but it requires so much human maintenance that the ROI never materializes. Sometimes it is actually worse than the manual process it replaced, because now you need both technical skills to fix the automation, domain knowledge to handle the exceptions, right? All right. So it's further complicated though. Here's the core problem. Without proper error handling or handling architecture, every edge case becomes a manual intervention point. And here's what most builders don't realize. Edge cases aren't actually edge cases when you're operating at a scale. When you're processing 10,000 transactions a day, a 1 in 1,000 edge case happens 10 times a day. Okay. Let me give you a concrete example. Now, a healthcare, uh, a, a consultant of a student of mine who was supporting a healthcare client built an automation to process insurance claim submission. Okay, it worked great in testing with clean, complete data. In production, 15% of the claims had some variation, so missing optional fields, alternate formatting, typos in provider names, normal stuff in real data. I mean, All of you have seen it, right? Their initial automation treated each variation as a fatal error requiring human review. At 500 claims per day, that's 75 manual interventions, okay? Every day, their claims processor were spending more time reviewing automation failures than they used to spend processing claims manually. The automation technically worked, but it failed to deliver business value because it lacked intelligent error handling. So, what is the resolution? What 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 is the resolution of it? Okay, so here's what My apologies. I had a call, so not all failures. Sorry, I lost my train of thought for a minute. Give me a second. So we were talking about resolution framework, right? So we need to first make a self-healing architecture. Okay, not all failures are permanent. Okay, network miss timeouts, temporary API unavailability, or rate limit errors. These are transient failures that will succeed if you simply try again. But you can't just retry immediately in a loop, right? That's how you get banned from APIs or overwhelm already struggling systems. The solution is exponential backoff. Okay? Retry after 1 second, then 2 seconds, then 4 seconds, right? Then eight. Each retry gives the system more time to recover. Okay. And you set maximum retry limits so you don't retry forever. Of course, you don't want to be in a loop as well, right? So for that insurance claim system, uh, I recommend that he implement this pattern. Minor data validation errors triggers immediate retry after reformatting. API timeout errors, retry with exponential backoff up to 3 times. Only then, it, if all retries fails, right, does it escalate to him for human review. Result was the manual intervention dropped from 75 cases per day to fewer than 10. The automation now handles routine variations automatically, and humans focus on a genuinely ambiguous situations requiring judgment. Second is the intelligent escalation patterns. Okay, here's the principle that's fundamental to professional automation. Alerts humans only when automation has exhausted all recovery options. This is the opposite of how most systems work, which alert on every error, regardless of whether human intervention can actually help. So, intelligent escalation has tiers, right? On a first tier, automatic retry handles transient failures. Second tier, fallback procedures handle common variations. And third tier, partial completion allows workflow to continue even with degraded functionality. And fourth tier, human escalation for situations requiring the judgment. Okay. The key is logging. The key is logging The key is logging all automatic recoveries so you can analyze patterns. Or here's the best case for me to remember for next time: turn off all your phones. Uh, Sorry about the disruption. The key is logging all automatic recoveries so you can analyze patterns. Maybe certain API, right? Maybe specific data formats caused repeated issues. This analysis lets you improve automation proactively rather than reactively responding to each failure. And the third, build feedback loops. Okay, this is where amateur automation and pro truly diverge. Professionals build systems that learn from failures and improve over time. Implement comprehensive logging that captures what failed, when it failed, and what data was being processed, what recovery actions were attempted, and whether those actions succeeded. Store this in a structured format you can analyze, uh, and then regularly review failures. Okay, review failure patterns. If you see the same error occurring repeatedly, That's not an edge case. It's a workflow. It's a workflow deficiency. Update your automation to handle that pattern natively rather than treating it as an exception every time. For healthcare client, failure analysis revealed that three specific data variations accounted for 70% of escalations, right? We added pre-processing nodes to handle those patterns, and and manual intervention dropped from another 40%. So the core principle is optimization, not elimination. I want to be very clear about something. Okay, automation doesn't eliminate humans. Okay, it optimizes their involvement. This mental shift is crucial. When you try to eliminate humans entirely, you build brittle systems that fall catastrophically. Okay, when you enter anything, when you encounter anything unexpected, right? Because it is AI, it's not human. Okay, when you optimize human involvement, you build resilient systems that escalate intelligently. Your goal isn't zero human intervention. Your goal is that humans is intervene only when their expertise adds value, when judgment is required, when exceptions truly are exceptional, when when strategic decisions need to be made. Routine variations, transient failures, predictable patterns, automation should handle these you know automatically. Okay, when you achieve this balance, you get the best of the both worlds. The speed and consistency of automation combined with the judgment and flexibility of human expertise. All right, that's when ROI becomes real. So let me go to the next slide. So, one of the most common ways automation breaks in